Yep, thank you. All right, so I made this thing that looks like this when you run the code. It helps people make decisions under extreme uncertainty. In this case, you're seeing a comparison of 3 different mitigation plans. So things we're doing to reduce the risk. I wanted to start with this slide just to begin with the end in mind. So unsuR is the name of the package I'm working on that helps people do risk assessments. Risk assessment is something you do to inform decisions that involve a lot of uncertainty. And cybersecurity is in parentheses because you can really use this for a variety of things. Under the hood, the methods are applied to space shuttle launches, insurance quotes, investment portfolios, counterterrorism, or determining which coffee brand is most worth it after factoring in price tag, enjoyment, grams of coffee required for a good cup, and ethical preferences on suppliers. So the risk assessment story in my work begins with excited people who want to use exciting new technologies to handle non-public data like health information or the PII that we've seen in some other presentations, or just that was mentioned in other presentations. So if a data scientist were to ask about using R to handle patient data, someone somewhere has to do risk assessments, and that's where I get involved. So in my old job, I got data from a fancy mass spectrometer like this. It told me exactly what periodic table elements were in a sample. In other areas of work, people get survey data from a lot of people to understand their feelings on certain topics. In cybersecurity, you have one data breach and you go bankrupt. And then there's nobody left to answer survey questions or to contribute to root cause analysis data set, or if they are available, there's obviously a lot of bias. So how do we measure risk in cybersecurity? How does NASA measure risk without experimenting by blowing up tons of rockets just to see what the probabilities of things are? I invite each of you to ask the people in charge of protecting your data, how do you measure risk for us? Ask them to see specifically how they quantify it. Most likely you're going to see something like this, a table of scary events on the left and scores on the right. These probability scores are then multiplied by the impact scores, yielding a risk score. The scores don't come from studies or special analyses most of the time. They come from usually 1 or 2 experts or analysts in the organization who just pick a number. If you do what the security and compliance people say to do to mitigate risk, like mandate that people use firewalls and antivirus, we say you'll have a reduced risk you will have reduced risk from high to medium. But when the CFO asks how much is reasonable to spend on those security things, how do we measure the distance between high and medium? It's one of life's great mysteries to many compliance and risk analysts. There's a growing movement in favor of methods that use real math and actually improve decisions, unlike ordinal scores and heat maps. Legitimate methods have been around for 40 years or more, and you'll find they're used in actuarial science, ecology, engineering, and finance, but not many people can afford the expertise or tools required to use them. The package I'm presenting today, called unsuR, is my attempt to provide an open source and free option that adheres to the literature but remains accessible. We start by moving away from scores from experts with definitions like high risk versus very high risk, and we instead ask our experts for actual numbers like, I can see this attack playing out on our servers twice in 7 years. And then for characterizing the impact of scary events, data breaches and such, if these servers were to get hacked, we're talking $1 million in losses, but due to the breach fines and the lawsuits, it could be as high as $6 million, I'm not sure. Range estimates like this are great because they allow our experts to express their uncertainty. Uncertainty can and should be included in our risk models. Also, something you can't do with high, medium, and low scores is capture that uncertainty. The problem now is that you can't, the problem now once you have these ranges that you can't, you can't multiply ranges with each other. So probability ranges and impact ranges for another risk product. That's where R comes in. So shrug dude ASCII is pleased. He has gone from shrugging to excitedly measuring things in probabilities in dollars. I discovered that you can do that with the shrug ASCII by accident. In practice, here are the risk scenarios on the left with estimates from subject matter experts on the right instead of scores. So to the analysts that usually give scores, or the subject matter experts that you ask for this information, CFO might provide the financials, the cybersecurity folks might provide the probabilities. It looks like this after you've decided you're going to collect ranges instead. After we collect those ranges from experts, we use Monte Carlo simulation in R to create a data set that fills in the ranges. The result is a synthetic but representative data set that can be analyzed using your R package and technique of choice. Instead of bogus heat maps, you can create visualizations and statistical summaries that actually illustrate the risk. Again, Shrugged ASCII is pleased, but he may be measuring the distance between two unrelated box plots here, but that's okay. It's a start. It's still better than what we were using before. This is the interactive dashboard I showed earlier. I made it for executives who asked for the risk, wanted a quick picture. There are tabs that you can click through. There's a demo on the GitHub repo for this. At the end of the presentation, you'll see the links. I don't know how to develop websites, program, or do long division, but I made this in R. And now every time we do a risk assessment, I use the same code. I just feed in the latest estimates and commentary. And then as the R community develops, this free open source tool develops too. So I'm going to rapidly flash blocks of code at you just to get the gist. I'm not going to spend too much time on the actual R code. You can search GitHub for Neskey or unsuR to deep dive. In RStudio, you can collapse code chunks to help maintain sanity. This is the collapse code chunk outline of unsuR pasted into a Flex dashboard markdown template. Flex dashboard is not a requirement, but rapidly impresses your bosses and friends with dashboards like the one I just showed. The dashboard header is at the top. Then we load those R packages that other people made. We set parameters like the URL or the file path where your sheet is that has those estimates, or a database table. Then you have preprocessing of the spreadsheet input into a format that's more conducive to the calculations and visualizations that are happening. A print-friendly tab is also available for when the hype of a dashboard wears down and your boss asks for something that they can print out. This almost always happens, unfortunately. The external libraries called are for interacting with Google Drive if your input data is there, and the rest are mostly for data visualization. For those new to R, the libraries are the giants whose shoulders are being stood on to make this possible. Packages in their libraries are the best part of using R. I wrote 3 local functions that do the scenario combination, the Monte Carlo loop, and the parameterized random number generation for the Monte Carlo. The distribution chosen for the random number generation is called beta PERT, which was popularized by the EPA and NASA for project planning and risk assessment. The combo generator shown here, it's taking these inputs from the Google Sheet or the Excel sheet. Those are the screenshots, and then the code is processing that. It combines a list of technologies and verbs involved in all possible combinations of the risk scenarios we come up with, then removes semantically nonsensical things like external attackers accidentally hacking your network, which again is a list of scenarios that your experts can provide those estimates for. If the scenario development is overkill, people can also just list their own scenarios, just the sentences. The Monte Carlo loop generates random numbers according to parameters you specify. This is the heart of the simulation. The thing on the right is just a table summarizing what Monte Carlo does. It generates the random probability value, the random impact value, and then in a way multiplies those together. The beta PERT function used in the Monte Carlo simulation, part of unsuR, generates random numbers that fall within an expert's estimate range, like this event, this bad thing will cost us $100 to $500,000, but they're not sure where in between. It also allows the expert to provide a most likely estimate, and the random number generation will favor that. So if they said it's more likely on the low end, $200, the random numbers are going to be more often around there. Beta PERT is more intuitive to experts if you know the phenomenon is normally distributed and you just pick the most likely that is midway between your range. If you want to skew toward the low or high end, you just give the most likely number that's on the lower or high end of the range you provided. So again, these are those estimates that are being elicited, and what they look like. You're literally typing those into a cell or into a form that goes into a database, wherever your company is at. So those were the custom functions they made back to the main script, the unsuR.rmd, which probably all be functions if I was any good at coding. There's a lot of efficiency that can be made here. So this is where you tell unsuR where the estimates are, the file path or the URL. You put in an email address if it's a Google Sheet that has authentication requirements, which in risk and security, it often does. Here the spreadsheets are read into memory and named. It's really just simply, there are several sheets in your workbook, you're naming them so that the code knows what to do with them, where the data is. This is the Monte Carlo simulation. This simulates the synthetic data set that fits the parameters provided by the expert. So instead of probability scores times impact scores, you're getting probability data set times impact data set equals risk. unsuR optionally collects known costs and benefits of your technology and creates data sets in the same way. So you can say that the risk that these security people are bickering about is worth the rewards. You can actually give a number and you can actually have that conversation and have a voice and couldn't help say, look, we know there's risk to having our studio in our environments, but this is all the value it provides. You can help come up with an estimate and a number, and they can put against that, here's the cost of the risk that we're thinking about, and then you can work at different mitigation strategies to come to an agreement. The benefits and costs, even though they're intangible, can be intangibles, like how annoying controls can be to users, like security training. Our users are frustrated. They would pay this much money to not have to do the cybersecurity training, or they think it's not productive. You can try to collect intangibles like that. The rest of the unsuR.rmd file is the Cyx dashboard, markdown stuff. It consists of tables and plots that describe the simulation data and renders them as the web page with tabs I've shown a few times. So this is just the different plots that are typically used in our risk assessment reports arrayed out. This is my favorite plots, the inverse empirical cumulative distribution function. In risk, they just call it the loss exceedance curve. So these are great because they don't underrepresent the black swans, heavy tails, and long tails that are so common in risk assessment. And it reads like plan A, yellow, which is the plan where we don't implement any security controls, gives us a 93% probability of losing more than $250,000. Plan B, green, the first set of security recommendations, say cybersecurity training, gives us a 68% chance of losses exceeding $250,000, and so on. So that's the output of providing all those individual estimates and how they come together. The chart and set of statements illustrates to executives the relative risk of doing nothing versus doing control B versus doing control C. But unsuR also calculates the difference between those control plans so that you can say, you can actually quantify the value of the security control to the organization. That enables you to answer questions like, is dropping $1 million on an enterprise firewall worth it if the data breaches of the servers behind the firewall would never exceed a few $100s? It also enables you to explain how many years it would take to pay off that firewall investment if in the value of avoided costs due to data breaches and the like over time. These are cybersecurity examples, but really R is just enabling us to make decisions where we're just, well, unsuR. The code's on GitHub. The repo is called unsuR. It's not in CRAN yet, and I'm working on it. And that's all I got. Q&A. I could comment on the lessons learned. I made a really ugly set of R code here, and I fixed it as I've learned new things. There's use of pipe and then not use of pipe that people cringe at when they see it. I prototyped it in Excel originally. which I know is embarrassing for a lot of people with macros, but I had to do it that way because I was new to R, and it worked, and it was okay. Yeah.
Do you mind expanding on that thought, like coming from Excel and actually prototyping in Excel and actually creating a product like this? What was that experience like?
I mean, I started that way because originally Python was what I was aware of for solving these kinds of problems using Monte Carlo. And the business I worked for at the time was a federal defense financial institution, and they were like, no, none of that Python and R hacker stuff. Like, we're not gonna allow that on our networks. And so what can you use? And they're like, Microsoft, sweet. Okay. So I had to create something in Excel, and I don't think a lot of them realize that Visual Basic and all the macros and stuff are in the background, so you can still code. And so that's where I built the original template. And it was, I mean, it works. And in fact, some people prefer that package, that Excel workbook, and sometimes I give that to them because they don't want to stand up RStudio and they just want to get something done real fast, and it's better for them. But you can just do a lot more with the visualizations and like the collaborative contributions to the tool with R, and I really think that's worth it.
We have one more question. If corporate types still want to see high, medium, and low heat maps, how does your output better provide this?
So you can translate the output into high, medium, and low and heat maps if you want, but what's nice is that now you're doing it with a high integrity analysis. It's based on judgment and decision-making psychology, and how the estimates are listed and how you're processing the data. And then the product of all of that analysis is a heat map and a score. And then it's okay to use heat maps and scores. So we can do that. We can do that for them. But that will cause issues when you're trying to communicate, is the control worth it? And how much money is it worth? You know, if it's a high, where does the control sit? Is the control like a medium control? It somehow reduces high to medium. So that people tend to prefer the numbers once they start asking the real questions like, well, how much money do we have?